All right, so on Monday we did circles, ellipses, and hyperbolas. So tonight we're going to look at parabolas, and then we're going to actually look at systems of equations using quadratics and nonlinear functions, basically. So quadratics, so parabolas, ellipses, circles, how they intersect. And I'll show you a couple of tricks to make those problems a little bit simpler. All right, so parabolas we've done a lot before. The only thing that's going to be changed in what we're going to look at tonight is we're going to add in y squared ones. So we're going to be going the opposite direction. Instead of just doing the up and the down, we're going to also do left and right. And we're also going to be adding in looking for the directrix and the focus. Remember we had the foci and the ellipses. We're going to have one of those in the parabola as well. So those are the other couple pieces that we're going to look at being able to find and use. But let's start off with a simple one. We're looking at for the range of a quadratic function. So to find range, we need to find our vertex. Normally, I would tell you a really simple way to do this with just find the vertex. However, we need to use the vertex form in a lot of other problems. So I'm going to actually show you how to get the vertex form for this one. So we've got g of x equals 3x squared minus 6x plus 4. And it's very similar to what we did on Monday. So we're going to take out the 3. We have x squared minus 2x plus 4. Now I need to add something on the inside. So I'm going to take that negative 2, and we're going to do that divide by 2 and squared. So negative 2 divided by 2 is negative 1. Squared is 1. So I'm adding 1 on the inside. Since I added 1 on the inside, I really added 3 because that 3 is on the outside of there. Since I added 3, I have to subtract 3 from the problem to balance the equation. So on Monday, we actually added it to both sides of the equation to balance it. On this one, we're doing it only on one side, so we have to add and subtract it. So we're going to have the 3, and now this becomes x minus 1 squared minus 3. Nope, not minus 3. Plus 1. So my vertex is h comma k. And in this format, it's a x minus h squared plus k. So my vertex in this problem is 1, 1. Now, they wanted the range. So we know this for graph. We have to figure out, does it open up or open down? So if the number in front, so if a is positive, it opens up. Is negative, it opens down. So if it opens up, then it's going to be my y value to positive infinity. If it opens down, it'll be negative infinity to my y value of my vertex. So in this case, it opens up. So my range is going to be 1 to infinity. And we put a bracket at 1 because we do include the 1 because it does go to that point, and you never put a bracket for infinity. So that's a pretty simple one, very similar to other stuff that we've done in the past. So, all right. Graphing the parabola. Now, when you're graphing a parabola in on this one, it wants you to do your vertex, the direction, and one other point. So all we really need to find is our vertex and 1 point on the actual parabola. So this one, we have y squared equals negative 4x. So again, I'm going to bring the negative 4 over, or divide. So I have 1/4 y squared equals x. And I want to get the y squared by itself. So now that means that this function, since the number in front, if it's the y, is positive, it opens to the right. If it's negative, it opens to the left. So I know this one is opening left. So it's going to go like that. Now I just need to find my vertex. So the vertex, again, is just the same thing. It's H and K. However, there's nothing added to this problem. So my vertex is actually going to be 0, 0. So, and then I need to find one more point. So I'm going to plug in 4 for y, or actually 2 for y, because I want to get rid of the 1/4 in the fraction. So 2 squared. So that's 4. 4 times negative 1/4 is negative 1. So that's my x. Notice how I plugged in the number for the y and not the x, because it's y squared, and I would have to solve for y to do it the other way. So it just makes it easier to do it this way. So I know my graph is, my vertex is at 0, 0. It's going to go this way. And my next point is at 1, or 0, 0 that way, negative 1, and 2. And we graph it. Let's do one more of those to see if it gives you, nope, all these are going to be 0, 0s. So see if they actually give you one that's not. Yeah, this one's always going to give you the 0, 0 one. So, all right. Next one, same thing, except we actually have to do some solving in it. Now, one of the key big pieces, and I'll use this to show you some notes, is remember I had the equation, the y equals a x minus h squared plus k. That's the x one. If we're doing the y, the k and the h switch, because k goes with the y and h goes with the x. So the k and the h switch. However, your vertex is still h comma k. So just keep that in mind. All right, so now I've got to break this problem down basically. So I have negative 3y squared plus 18y minus 26, and I'm going to move the x over to the other side. So now I'm going to factor this out. So I pull out the negative 3. I have y squared minus 6y minus 26 equals x. I take that negative 6, divide by 2, square it. So it's negative 3 squared, which is 9. So y squared minus 6y plus 9 minus 26. So I added a negative 27 inside. So I have to add 27 outside. Squared plus 1 equals x. So we do the same thing for this one. I need to find my vertex and then one other point. So my vertex in this case is h, which is in the outside, this case 1, and k, which is 3. So that's the k, and that's the h. And then I just need one more point. So I'm going to do 3 for y. Oh, I can't do 3 for y. That would give me my vertex. Let's do 2 for y. So if I plug in 2, 2 minus 3 squared plus 1. So negative 1 squared is 1. 1 times negative 3 is negative 3. Plus 1 is negative 2. So now we graph this one. It's the y one, so I'm going to place my vertex at 1, 3. It is a negative a, so it's going to go this direction again. And my next point is at negative 2, 2. The other way you could figure out the direction it goes is just looking at your other point. So obviously it's not going this way if my next point is negative 2, 2. So that's another, just a little check to make sure that you got your points and everything else correctly and your sign's correct. I think that's the last graph one, so yeah. Any questions on the graphing before I go on to the next set? And I never did get the chat fixed. So if you have a question, you have to unmute and ask. Well, I got the chat's working for some people, just not everybody. So for this one, it's your vertex. That's your K because it's Y minus K. So that's K. And then that's your H. So that's where the 1 came from for the H. So that's H is always the first value. Your vertex is always H comma K. And the sign switches on the one on the inside because it's always Y minus or X minus. So whatever sign's in there, I basically want the other one. No problem. All right. The next set of problems we're actually going to work on coming up with the equation form. So let's look at the example. We'll give you some notes for this. So the first set of notes you're going to want to write down is the actual form of the equation. So you have the x minus, so if it opens up or down, you have x minus h squared equals 4p y minus k. Left to right, it's the y minus k squared equals 4p x minus h. The p is going to tell you if it opens left or right, just like the a does. So that 4p is basically your a. So it's 1 over 4p equals a in the other type of equation that we had. The p is going to give me how far away from the vertex the focus is and the directrix. So that's what that p is going to come in. I'll show you that in a second. So make sure you have these equations written down because these are the format that we're going to want these equations in. So, and then I know, oh, there it is. So as you can see right here, this is the general setup of your equation. So we have, or the function, or the graph. So we have the parabola, you have the axis of symmetry and the vertex, which is the stuff we typically would talk about when we're dealing with a parabola. Now, we also have the focus, which we talked about on Monday with the ellipses and the hyperbolas, and the directrix. The focus is inside the parabola, and that's where the light's going to be focused to. The directrix is exactly the same distance from the vertex as the focus is on the other side. So we need those pieces of information to be able to figure the actual graph out. All right, so now let's look at this equation. So we've got my vertex is 5, negative 5. So that's my h, and that's my k. My directrix is y equals negative 13. So that means that if I do a quick little sketch of this graph, 5, negative 5, so my vertex is going to be there. So 5, negative 5, and that is the y equals negative 13. So that means my graph is going to go up something like that. So we need to figure out my p. So the p is the value from here to here. So if I'm starting at negative 5 and going to negative 13, that's minus 8. So p is 8. Since this graph opens up, it's a positive 8. If it opened down, it'd be a negative 8. So this graph opens up. So I'm going to use the x minus h squared equals 4p y plus k. Is y plus k or minus k? I always get those signs mixed up. Nope, it's minus k. So we're going to plug in our information that we know. So I have x, I have h is 5 squared. I know my p is 8, and I have y minus -5. So my equation is 32, y plus 5. And you don't have to break this up. It takes the parentheses for this topic. So it's really just finding h, k, and p, and then we can get our equations. It's just what information are they giving you to get your vertex and your p-value to find it, which is in essence all the rest of most of the rest of the problems that we're going to do. They're just going to be increasingly different options they gave you. All right, so now this one gives you your focus in my Directrix. So if we do it again, the easiest way to do these is to just do a quick little sketch of it. This way, not only do you see where the information is, but you can then use that to figure out if you have a mistake or if something just doesn't make sense. So my focus is at -6, 1. So my focus is right there. And my Directrix is at x equals -2. So that means my graph, or my quick little sketch of this, is got to go this way. And my vertex is somewhere in here. Now my vertex is exactly halfway between the focus and the Directrix. So my y value, so my vertex, the y value is going to stay the same because it's on that same y line. And my focus is -6 and my Directrix is -2. So if I was to add those, I get -8, divide by 2, my vertex is going to be at -4, 1. Because that's exactly halfway between -6, 1, and the line -2. So that's my h, and that's my k. Now my p-value is the difference from my vertex to my focus or to the Directrix. It doesn't make much difference. So in this case, my p is 2, and I know it's going to be negative because it's going to the left. So now we can write my equation. Since this one's a y, so I'm going to do y minus k squared equals 4p x minus h. So it's y minus 1 squared equals -8 x plus 4. I see dots are clicking. Any questions on this one, or do you want me to go on? So the vertex, so your vertex is on your parabola. The vertex is always going to be in between your focus and your Directrix. So in this case, They gave me my focus is -6, 1, and my directrix is at x equals -2. So if you remember from when we originally did parabolas, we have an axis of symmetry. So my axis of symmetry for this problem is y equals 1. So that means my vertex is on that axis of symmetry. So that's where that 1 came from. The -4 came from because I know I have -6, 1, and I have -2 something. It doesn't make much difference what that number is. We'll put the 1. And then I know my vertex has to be directly in the center of this. So the number that makes sense is -4, 1. So that's your H and your K. We're going to do it a few more times anyway. There's a couple more problems that are basically the same. So this one wants me to find my focus of the parabola. So in this problem, I need to actually get it into the correct format to find P, find my vertex, and then I can figure out my focus from there. So we've got y squared minus 4y plus 5x minus 6 equals 0. So I'm going to move the 5x and the 6 over to this side. Minus 6. And now I got to figure out this part over here. So, because I got to get this into the squared part. So I'm going to add, so I got -2 divided by 2 squared. Oh, sorry, -4 divided by 2. So it's -2 squared, which is 4. So y squared minus 4y plus 4 equals -5x minus 6 plus 4. So this is y minus 2 squared. And now this, I've got to get it to equal, so I've got -5x minus 2. So I've got to get this to be with the parentheses. So I got to pull that -5 out. So I have -5x, and if I'm dividing that by -5, I get positive 2/5. So that's my K, that's my H, and that is 4P. So I know my vertex. My vertex is 2/5, -2. Oh, not -2, +2. I have my signs backwards. So it's -2/5 and +2. Now I need to figure out my P. So 4P equals -5. So P equals -5/4. Now I'm going to be adding this. So the focus, so I know my quick little graph of this. My vertex, because I divided the whole problem, this whole side by -5. That's how that 2/5 became there. And it's always the opposite sign because it's x minus that. So to get x minus, it'd have to be x minus a -2 or 2/5. And that's where it becomes the h is -2/5. So my vertex is negative, like right about here. That's my vertex. My P is negative. So I know my graph's going that direction because it's the y. So my focus is going to be somewhere over here. So I'm adding, or actually, I'm going to take that and go that way. So it's a -2/5 minus 5/4, which gives me, I'm gonna get a common denominator, 20. So -8 and -25 is -33/20. So my focus is -33/20 and then 2. And if I did all my fractions correct, I'll have the answer correct. Yep. I just don't feel like going through doing my fractions again. Where's my Oh, I messed my sign up when I moved the 6 over. So when I moved the 6 over, I left it negative. That was the mistake right there. Everything else was right. The process was all right. I just messed up my sign on the 6. We'll do one more without my mess up of my signs. So we've got -y² minus 8y equals -5x plus 21. So I'm pulling out the negative sign, plus 8y. And I'm going to pull out the -5 on this side, so I get x. Actually, let's not do that yet. So 8 divided by 2 is 4. 4 squared is 16. So I've got a -16 on this side, so I'm going to do a -16 on this side. So it's negative y plus 4 squared equals -5x plus 5. I'm going to pull out a -5, so I get x minus 1. And I'm going to get rid of that negative sign on both sides. So my vertex is 1, -4, just from the numbers that are right there. That's the h and that's the k. And 4p is 5. So that means p is going to be 5/4. Now we're going to see if I messed up my signs by taking out the negative signs. So my vertex is 1, -4, so it's right down there. It's positive, so I'm believing it's going this way. I did mess up. I did take out signs, so it's very possible that I messed up the signs. We'll see in a second. And so I'm going to add. So I'm going to take that 1, and I'm going to add 5/4 to it, and that means I get 9/4. So my focus is 9/4 -4. And if I messed up my signs, it'll be -1/4. Oh, good. Now that we've actually done it with the correct numbers, the fractions normally that came out a little bit easier. I'm going to bet that if you get something crazy with your fractions, like we did in the last one that I got wrong with because I messed up the sign, go back and look at it because they're probably not going to give you something completely crazy when you're doing it. So it's very possible that if you've got something crazy, you probably messed up your sign. A fraction's not necessarily crazy, but when you're adding multiple fractions or have a fraction as a vertex, just go back and look at it. It's possible they're going to give you one like that, but it's just something to go back and look at. All right. So now the next one, they want us to come up with the equation for it. So they're going to give you they're always going to have to give you the vertex. So in a parabola, as long as they give you the vertex and one other point, I can find my equation for it. So in this case, they got the vertex is -3, 5. So that's h and k. And they gave me a point, -2, 1, which is x and y. Now, this graph goes to the right, so I know it's going to be that y1. So it's y minus k squared equals 4p x minus h. So let's plug in everything I know, and basically we get to find p. So the y is 1, so 1 minus 5 squared equals 4p x plus 3. Oh, not x plus 3. -2 plus 3. So I got -4 squared equals negative, that's 1 times 4 is 4p. So this is 16 equals 4p. So p equals, so 4 equals p. Now that we got p, we're going to basically retype the equation in, except just don't use the 8y and the x. So it's y minus 5 squared equals 4p. So 4 times, well, you have the 4p. The 4p is 16. And then x minus, or plus 3. So the nice thing is once you have the 4p, you basically can stop there because you actually want 4p. So finding the p just makes you go back that step anyway. I think actually that's the last of the parabolas. Yeah. Any questions with the parabolas before we go on to the next part? All right. So the next question is just a one-off topic where they're basically going to give you two equations and you have to tell me which conic it is. So here's a quick little reminder of what all the different equations were and what they looked like and stuff like that. So a couple quick little things when you're looking at this. You don't necessarily have to solve it into that format, but there are some things that you can use to try to figure out which one it's going to be. So the circle and the ellipse has an addition between the two. So that basically means your y is going to have to be, like, your y and your x are going to be positive. Your hyperbola, one of them is going to be negative because that's how you get the negative subtraction piece in there. So if your y and your x are both positive, you're probably not having a hyperbola. If your y and your x are, one of them is negative, then it's a hyperbola. So you can basically pull out the hyperbolas pretty quick. The circle and the ellipse, the main difference between the circle and the ellipse is that A and B are the same in a circle, and that ends up being your radius. So if you can look at the numbers in front and like if there's going to come out to basically be the same piece, it's probably going to be a circle. A parabola is another one that's really easy to find. There's only one squared in it. Everything else has got two squares. So you don't necessarily have to solve it. If you see just one square, like x squared or y squared, it's going to be a parabola. So let's go back and look at this. So the first one, I have an x squared and a y squared. So that one's most likely going to either be a or a ellipse or a circle. The second one, I've got a negative 16x squared and a 4y squared. That one I know is going to be a hyperbola because of the squared. And they want us to find the center. So we do actually have to solve them out. So they want the vertex. So now that we found that it's a hyperbola, I actually have to solve it. I didn't realize they were going to ask that question. That makes the circle and the ellipse really easy because you have to solve it anyway. So negative 16x squared plus 32x. Let's put the 4y squared first. So 4y squared minus 8y, negative 16x squared plus 32. And then equals negative 52. So I pull out the 4, I get y squared minus 2y. I pull out the negative 16, I get x squared minus 2x. So now I'm going to take the y squared minus 2y. I have to find the number that multiplies to that. So I'm going to add 1 into this one. And then the 16, negative 2, same thing. I'm going to add 1. So I get 4 y minus 1 squared minus 16 x minus 1 squared equals negative 52, and I've added a 4 and a minus 16. So we've got negative 68 plus 4 is negative 64. Now, I actually don't have to go any further than we're here. I don't need to finish the problem. I just needed to find my center in this one. So that's going to be that value and that value. So in this case, my center is 1 and 1. I could divide everything by the negative 64 or the 64 and change it around. But in this case, I really didn't actually have to do that because I was just looking for the center anyway. Now, let's do the first one. So I have 3x squared plus 18x plus 3y squared plus 12y equals 9. So plot the 3, x squared plus 6x plus 3y squared plus 4y. So this one, 6 divided by 2 is 3, 3 squared is 9. 4 divided by 2 squared is 4. So I'm adding 27 and I'm adding 12. So I get 3 x squared plus x plus 3 squared plus 3y plus 2 squared equals 3648. Yeah. So in this case, I can tell you it's a circle without doing anything else other than what I've got right here, because those two numbers right there are the same. So if I was to divide by the 48, I'm going to get the exact same number underneath. So I know it's a circle. And they want the center, which in this case is -3, -2, because it's the middle points. So the key is don't do more than you have to do to find it. I have a feeling most of the time they're going to ask you for center, but maybe not always. Let's just look at the example and see if they ask you for something different. Yeah, they asked for the vertex in the center, and vertex is just a parabola for the center. So if you look at this one, you can tell that the first one's a parabola because it's just an x squared in it. The second one is an ellipse. They're both negative. So you have a negative x squared and a negative 16y squared. So since they're the same, I know it's not a hyperbola. So then it's just a matter of solving it and figuring out if it's an ellipse or a circle. In this case, if you look at it, we're going to have a -1 in front of one and a -16 in front of the other one. So those are both different numbers. So then I know it's an ellipse. So this topic kind of basically brings everything together and says, okay, do you really understand which ones they all are? All right. Now, when you're graphing these, you cannot use Desmos to find the answer, because a lot of times the answers are going to be like not exact numbers, and you still have to actually graph them in Alex anyway. So, but what I want you to use Desmos for is, one, to figure out exactly how many solutions there are, and to give you a general idea of what they look like, so you know you graphed it correctly. So in this case, we have y equals 2x and y equals 2x squared minus 4. So we're looking for where they cross. And actually, in this case, they actually come out to be nice and easy ones. So we know it crosses twice. So now we've got to graph them. The first one is a line. To graph a linear equation, we just do the y equals mx plus b. So in this case, it's my vertex is at 0, or my 1 point's at 0, 0, and I'm going to go up 2 and over 1. So there's that equation. The next one is a parabola. So let's see, they need. So the same piece of information: vertex, which direction, and how many, and one other point. So the nice thing is, if you want, and I honestly, it's fine with me, you can use Desmos to find your vertex, and you already have, if you have a point. So if it works on Desmos nice, you can use Desmos to graph it. If it doesn't work on Desmos nice, then you have to actually graph it out. So stay there. So this one is at 0, -4, and it's opening up, and my next point's right there. So the solutions for this one are -1, -2, or 2, 4. Now, I am going to show you how to find those. How is my graph incorrect? Oh, that's why. It would help if I actually clicked my graph, my parabola right up, and that 2, 4. There you go. Now, I will show you how to find the answer without using Desmos. So once you have them solved for a letter, we can plug back in and actually basically solve out the equation. So the first one is y equals 2x. So I'm going to take that second equation, I'm going to do 2x equals 2x squared minus 4. So 0 equals 2x squared minus 2x minus 4. So I can take the whole problem and divide by 2. So x squared minus x minus 2. So then I can factor that. So I've got x minus 2 and x minus 1. Oh, x plus 1. So I know x equals 2 and negative 1. And then you just plug them back in to find the y's. So if it doesn't come out to be a nice answer in Desmos, that's how you'd actually solve it there too. But use Desmos to for the beginning. And yes, you can use Desmos on your test, on the test for it, and on the final. So. All right. Let's graph this one and see what we get. Three. All right, so now this one, they're only looking for the solution. So you didn't actually have to graph it. So it has 2 solutions, there and there. And this one's the same as the other one we just did in terms of how you would solve it if it didn't come out nice on Desmos. So you're just basically plugging the values in and then factoring it out. So we've got negative 9, 15, and negative 2, negative 13. All right. So 18x squared plus 8x minus y equals negative 4 and negative 2x squared. Don't worry, I'll show you how to solve this one out after we get the answers, if they work out nice. All right. So you can see how these answers aren't very nice answers. Well, the first one kind of is. The second one is not. Desmos will always round, and they don't want they want exact values in Alex. They don't want decimal answers. So this one we're going to have to solve out. But I know there's only going to be 2 answers for this one. So we can hit the OR button there. All right. So the first thing I have to do is I'm going to solve them for y's. So my first equation is 18x squared plus 8x plus 4 equals y. And negative 2x squared minus 6x plus 2 equals y. Now, the nice thing is the way this is set up right here, if I substitute it, I'm going to have to bring them all over anyway. So I'm actually just going to do process of elimination. I'm going to change all the signs down the bottom and add them together. So I get 20x squared plus 14x plus 2 equals 0. And now I can solve. So I can divide the whole problem by 2. Might make my life a little bit easier, smaller numbers. So I'm looking for 2 numbers that multiply to 10 and add to 7. So in this case, it's going to be 5x plus 1 and 2x plus 1. So my first x is negative 1/5, and my second x is negative 1/2. Now, if we look at Desmos to see if that's what I would have gotten, negative 1/2 and negative 1/5. So those answers do make sense for what I got in my graph. Now we're going to have to pick one and plug them back in. It doesn't make much difference which one you use. They're both not going to be that nice. So probably the second one is smaller numbers. So I have negative 2 times negative 1/5 squared minus 6 times negative 1/5 minus or plus 2 equals y. So I've got negative 2 over 25 plus 6 over 5 plus 2. So let's get them all to negative 25. So negative 2 over 25 plus 30 over 25 plus 50 over 25 and so I got 80 negative 2, so 78 over 25 equals y. And the answer was 3.12. That looks like 3.12. So that one's probably right. That's the other thing. Once you graph it, you can use that to figure out if you have the answer right, even coming up with the fractions, so you don't get them wrong, which is, and these problems are long enough, you really don't want to get them wrong and have to redo them. All right, so let's do the 1/2 one. So the same thing, negative 2 times negative 1/2 squared minus 6 times negative 1/2 plus 2. So it's 1/4, so it's negative 1/2 plus 3 plus 2. So 5 minus 1/2. So it's 9/2. So my first x was negative 1/5. And then I have 78 over 25. And then I have negative 1/2 and 9 over 2. Check my answers, and we got them right. So that's where you can use Desmos to help yourself. It's just not going to give you the complete answer. All right, one more problem. So x squared plus y squared equals 23, and 4x squared minus y squared equals 27. So the nice thing about Desmos is it can graph circles and hyperbolas and ellipses. So we know we're going to have 4 answers. We know approximately what our answers are. Now we have to find those answers. So it's not necessarily going to be, there's no way to get them from the actual graph to come up with the answers. So I know I'm going to have 4 answers, so I hit 4 answers there. So now let's organize the problem so I can solve it. When we're solving these, you can use any method of systems of equations to solve. So I have x squared plus y squared equals 23. Then I have 4x squared minus y squared equals 27. So honestly, this one's set up perfectly to do elimination. So I'm just going to add them. So 5x squared, the middle one's gone, that's 50. So divide by 5. So x squared equals 10. So x equals the square root of 10, plus or minus. So now that we got the square, x is the square root or plus or minus the square root of 10, I'm going to plug them back into the problem. So let's use the x squared plus y squared equals 23. So that we're going to do, we have to do it twice. So I'm going to do the square root of 10, so that's 10 plus y squared equals 23. So y squared equals 13. So y equals plus or minus the square root of 13. So I have my first set of points is square root of 10, square root of 13, square root of 10, and negative square root of 13. Now I have to do my negative 10. So I have negative 10 plus y squared equals 23. So y squared equals 33. So y equals square root of 33, plus or minus. So I have negative square root of 10, square root of 33, and negative square root of 10, negative square root of 33. And if we go back and look at Desmos for this, square root of 10 is square root of 10 is the 3.162. So that's right. Hold on, I messed something up. That's what I messed up. So when you plug in this, don't watch. Hold on, let me erase this part. This is what happens when you do not put parentheses when you plug things in. The negative square root of 10 squared is still 10. So I squared still equals plus or minus the square root of 13. So, and that's a great reason to use Desmos to help you figure it out, because I caught that mistake because I looked at it and noticed that all the other y's were the same. They were just pluses or minuses of them. So do them both and you say, oh, okay, that's where I made my mistake. So you can easily go back and fix it before you get the question wrong. And signs were my nemesis tonight. And that's it. So that's all the parabolas and the systems of nonlinear functions.